Good morning, friends. Myself, Dhaval Mistry. I am assistant professor in Mechanical Engineering Department in Mahatma Gandhi Institute of Technical Education and Research Center, which is situated in Navsari. Today, we are going to discuss on a presentation of gas welding. First, we discuss about gas welding, but the first definition of welding process is two similar or non-similar material are to be joined with or without the pressure and with or without the filler material. It's called a welding process. Then the types of welding process, there are many types of process. First one is gas welding process, then arc welding process, resistance welding, and atomic radiation welding. There are the types of welding process. So let's we first discuss about a gas welding. Gas welding, also called a oxy-fuel gas welding device, the heat from the combustion of a fuel gas such as acetylene in combination with oxygen. The process is a fusion welding process wherein joint is completely melted to the obtain the fusion. The fuel gas is generally used in acetylene because of high temperature generated in the flame. This process is called oxyacetylene welding. There are many types of gas: acetylene gas, propylene, propane, hydrogen, and neutral gas. The first, the gas is acetylene gas. Chemical formula is C2H2. The heat content is 55 mJ per meter cube and flame temperature is 3100 degree temperature. Then second gas is propylene. The chemical formula is C3H6. Heat content is 88 mJ per meter cube and the temperature of flame is 2500 degree Celsius. Then the third gas is propane. The chemical formula is C3H8. Heat content is 93 mJ per meter cube and the temperature of flame is 2450 degree Celsius. Then hydrogen. Hydrogen chemical formula is H2 and the heat content is 10 mJ per meter cube and the flame temperature is 2390 degrees Celsius. Then neutral gas. The neutral gases is the chemical formula is CH4 plus H2 and the heat content is 37 mJ per meter cube and the flame temperature is 2350 degree Celsius. The gas welding is a welding process that melt or joint melt by heating them with a flame causes by a reaction of fuel gas and oxygen. The most commonly used method is oxyacetylene welding due to the high flame temperature. The first type of is oxyacetylene gas welding. The principle of oxyacetylene gas welding is when the acetylene mix with the oxygen in correct proportion in the welding torch and ignite, the flame is produced which is sufficiently hot to melt and join the parent metal. Temperature of flame is about 3100 degrees Celsius. A filler rod is generally added to build up a seam for a greater strength. Utilization oxygen and a fuel gas to heat metal until it is a molten state and fuse multiple pieces of metal together can be used with or without a filler rod. Greater for brazing dissimilar metal together. Older technology that can be replaced by a GTAW. Then is next is chemical reaction and temperature distribution in a neutral oxyacetylene. See in a figure, there are the torch, gas, the primary combustion in inner cone is 2 by third total heat. Then the secondary combustion in outer envelope. See in a chemical formula, the inner cone and outer core. See in a figure. The secondary combination is also called a protection envelope since CO and H2 here are consume the O2 entering from the surrounding air, thereby the protecting the weld from oxidation. See in a figure, oxyacetylene welding use a high temperature flame from a combustion of acetylene and oxygen. A typical oxyacetylene welding operation, the mixture of C2H2 and O2, the welding torch tip, flame, solidification of weld metal. Say in a figure, the molten weld metal, base metal, and filler. This is the process of oxyacetylene gas welding. Then next topic is types of flame. There are three types of flame in a gas welding produced. The first one is a neutral flame, second one is a reducing flame, and third one is oxidizing flame. See in a figure, the first one is the neutral flame, then a reducing flame and oxidation flame. The first is the neutral flame. The temperature of its upper side is 1200 to 1300 degrees Celsius and inner cone is 3400 degrees Celsius. See in a detail, we discuss about in detail too for a neutral flame. A neutral flame is produced when the oxygen to acetylene ratio is 1.1 to 1. The temperature is the order of about 3200 degrees Celsius. The flame has a nicely defined inner cone, light blue in a color, and surrounding by the outer envelope, which is dark blue in a color than the inner cone. It is called a neutral because of it will not oxidize or carbonize the metal. It is used for welding of mild steel, stainless steel, copper, cast iron, and aluminium. Then second types of is the carburizing flame. It is also called a reducing flame. If the volume of oxygen supplied to the neutral flame is reduced, the resulting flame will be a carburizing or reducing flame rich in acetylene. In this flame, the acetylene feather exists between the inner cone and outer envelope. Temperature is the order about the 550 degree Faraday, less because it does not completely consume the available carbon. Metal that tend to absorb carbon should not be welded with a reducing flame. Carburizing flame contain more acetylene than a reducing flame. Carburizing flame is used for the welding to lead and for carburizing surface hardening purpose. Reducing flame is used with the low alloy steel rod for welding a high carbon steel. There is the reducing flame. Then the last one is the oxidizing flame. See in a figure. After the neutral flame, if the supply of oxygen is further increased, the result will be an oxidizing flame. Its inner cone is more pointed, outer flame envelope is much shorter. It burns with a loud roar. The temperature is the order of about the 6300 degree Faraday because of excess of A2, so complete combustion taken place. This flame is harmful for steel because of oxidizing the steel. Only if in the welding of copper and copper based alloy oxidation flame is the desirable because in those cases a thin protective layer of slag form over the molten metal. These are the types of flame. It is the most MP question. Then the types of welding. Types of gas welding technique. There are two types of technique. First one is the leftward welding technique and second one is the rightward welding technique. It is also called a forehead welding method and backhand welding method. See in a figure, first one is the leftward welding and then the rightward welding process. Discuss about in first one is leftward technique. The welder start welding at the right hand end of the joint and the proceed toward the left. The welding flame is direct away from the finished weld. Welding torch is given a small sideway movement while the filler rod is moved steadily across the seam. Good control and net appearances are obtained. It preheats the joint. If the workpiece thickness is more than 3 mm, bevel of plate is necessary and include angle of V joint 80 to 90 degrees so that it is economical. When the weld is recommenced, the tips of the causes weld contamination. Then the second rightward technique. Welding begin at the left hand end the joint and the proceed toward the right, hence the name is rightward technique. The torch flame is directed toward the complete weld since the flame is constantly directed on the edge of the V ahead of the weld puddles. No sideways motion of the torch is necessary, which result narrower V groove 30-degree bevel. The repeat are the heavier and spaced further apart. The rightward technique has got a certain advantages over the leftward. Up to 8 mm plate thickness, no bevel is necessary. This is reduce of the cost preparation of the edge and consumption of filler rod. For bigger thickness, include angle on of V be only 60-degree against the 80-degree in leftward technique. The welder's view of the weld pull and sides of and bottom of the V groove is unobstructed so better control is possible. The weld quality is the better, smaller total volume of deposit metal, reduce shrinkage and restoration. Because of less consumption of filler rod, cost of welding is less. This is the types of gas welding technique. Then is the gas welding. Gas weld, a sound weld is obtained by select a proper size flame, filler material and method of moving torch. The temperature generated during the process is 3300 degrees Celsius. This is the figure of the gas welding. See in a figure flow meter, oxygen regulator and acetylene. There are two gases are used in the gas welding. The direction of gas welding see the left to right. Then the scene figure valve, gas torch, workpiece. Then the last bottom of the figure oxyacetylene gas mixer, filler rod, protective envelope, metal droplet, base metal, weld pool, primary combustion, slag and weld metal. This is the complete of the gas welding process. Then is gas welding equipment. There are mainly gas equipment. First one is gas cylinder. Pressure of oxygen is 1 to 5 kg per centimeter square. Acetylene is 16 kg per centimeter square. Regulator. The working pressure of oxygen 1 kg per centimeter cube. Working pressure of the acetylene 0.15 kg per centimeter cube. Working pressure varies depend upon the thickness of the workpiece weld. Then the third is the pressure gauge, hoses and welding torch. In discuss we discuss first one is oxygen gas cylinder. Oxygen cylinder are paint black and wall outer are screw right handed. Acetylene gas cylinder. Acetylene gas cylinder is painted maroon and the wall are screwed left handed. To make this easily recognized, they are chamfering or grooving. Then the oxygen and acetylene pressure regulator. The pressure of the gas obtained from the cylinder or generator is considerably higher than the gas pressure used to operate the welding torch. The purpose of using gas pressure regulator is therefore to reduce the high pressure of the gas in the cylinder to suitable working pressure to produce a steady flow of gas under the varying cylinder pressure. A pressure regulator is fitted with the two pressure gauge, one for gas pressure in the cylinder and the other so the reducing pressure at which the gas is coming out. A pressure regulator is connected between the cylinder or generator and the hoses leading to welding torch. Then the oxygen and acetylene gas hose and hose connection. Hoses. Hoses. The hose of the supply of oxygen to the welding torch is colored blue and has the right-handed thread connection, whereas the acetylene hose is colored red and has the left-hand connection with the chamfering of grooving the nuts. Hose clamp. A metal clamp is used to attach the welding hose to a nipple. The clamp squeezes the hose around the nipple to prevent it from working loose. Hose coupler. These are used for joining a two pieces of welding hoses. Then the welding torch and blowpipe. The oxygen and the flue gases having been reduced in a pressure by the gas regulator are fed through a suitable hoses to a welding torch which mix and control the flow of gases to the welding nozzle or tips where the gas mixer is burned to produce a flame for carrying out gas. Welding operation. There are two types of welding torch are namely high pressure or equal pressure type, and second is low pressure or injector types of torch. There are the welding gas welding equipment. Okay, in this video we are converted covered a topic is the oxyacetylene gas welding and types of flame. There are the most IMP question asked in a GTU exam. Thank you.